Okay, so the next model I had asked to open was the basic health economics model, but before doing that, I actually did want to finish up a little bit of discussion of the this longitudinal data on history. On longitudinal on smoking history. And please forgive me, I had a major oversight. I was concentrating on features at an individual level, and then I realized there's actually something of great significance in this model which I didn't cover. And that's up in the main area of the model, the main class, which, as befits the main class, characterizes dynamics associated with the model as a whole. And what I put into place here was some mechanisms related to intervention. And I think Carlina had expressed some interest in having discussions of implementation. And there's a number of models I've shared with you which include representations of targeted interventions, situations where we can apply an intervention to certain segments of a population or different interventions. And we'll see how that takes place. But this model goes a step further, ladies and gentlemen, in one respect. And specifically, what it's characterizing here is some implementation science components associated with training for anti-tobacco education campaigns. So the idea here is that you have some training that goes on with respect to trainers who train peer educators, and these peer educators then will contribute to, so these graduated peer educators will then contribute to anti-tobacco efforts. So if we search in the model for peer educators, for example, we can find that at a person level, the cessation hazard for an individual, if we pop down to the person level, the cessation hazard here, this quit hazard associated with tobacco use, it is going to have some dependence on the smoking rate. On the availability of peer educators. So current cessation hazard here, just the left of this cessation rate. We're doing a bunch of work there, but it's governed by this hazard. And the hazard rate itself, ladies and gentlemen, basically takes into account some baseline hazard for cessation plus some influence of peer educators. And there's a beta effect expressing the effect of peer educators. Now, those peer educators could be captured very nicely in a hybrid model, and that's probably the next step for evolving this, where we individuate, we turn them into agents, and that's readily done. But right now, they affect this cessation hazard in sort of a classic statistical way. So they increase the cessation hazard by a certain amount per peer educator. Now, if we go and we look in Maine, we'll find that the availability of those peer educators is itself dependent on this training pipeline. And what this means is, if you start this model of smoking, you will find that over time the number of peer educators is rising. Okay, the number of peer educators is growing over time in accordance with this training pipeline. It is therefore imposing costs that are also climbing over time. These are accumulated, undiscounted costs that are accumulating. And the point is that this is occurring over the span of years, ladies and gentlemen. So if one's interested in, not just design of an intervention, trying to identify which gives the highest leverage, but in when that intervention will have effect, when it will start yielding big impacts in terms of cessation rates, in terms of the prevalence of smoking. If we're interested in understanding, in short, the implementation science, how the costs will be borne, whether tobacco taxes would cover these costs adequately or what have you, we may want to look at these dynamics. These dynamics will affect our capacity to roll out over time effective intervention programs and to secure the health benefits. And so when we look at the health benefits involved, when we look at statistics on the prevalence of smoking in the population or what have you, one of the things that we'll find is that it's mediated by these implementation science concerns.
So from a population perspective,
Yeah.
that means that as you're getting more and more trainers in
Yeah.
the system,
Yeah.
the odds of somebody wanting to stop smoking of getting into a program with trainers is
Yep.
going to increase.
That's right. So in other words, the odds of a given smoker getting exposed to a trainer will become higher as there's more and more. I should really talk about peer educators. There's trainers,
Yeah, right.
but the trainers train the peer educators, who then are the frontline people to deliver on the educational intervention. So the idea here is we're trying to trace through this training pipeline because it has big bearing on the timing of the health outcome measures that we're trying to impact. There's going to be some endogenous dynamics at a person level on how quickly heart disease outcomes show benefit due to smoking change. But then there's some impact, of the training process on how quickly even cessation rates will show changes. And so we're dealing with these different levels of delays, and if we need to advise someone on how quickly we would expect to see effects from an investment in this program, a model that takes into account explicitly these implementation science components can be valuable in bringing further understanding to the table.
Yeah.
So I thought that would be worth showing to the group, incorporating these implementation science components. Now, this model that Winchell's working on back there, it's a sugar-sweetened beverage model that takes a central focus on implementation science. And this is a model published, ladies and gentlemen, in the Journal of the Operations Research Society. And in this model, we are looking at the effects of sugar-sweetened beverage taxes on as providing a data source. As providing a financial source to invest in physical activity programs, as well as taking of course, the health gains that come from taxing sugar-sweetened beverages in terms of reduced consumption through elasticity, and understanding the ripple-through effects of that on weight levels, on the energy balance and weight change. And this model that Winchell's working on is adapting that to an agent-based context so you can have a highly heterogeneous population, whereas the original model was a system dynamics model that was operating with a typical child, etc. So there, the implementation science is also looking at issues of not only timing of rollout of new parks and how those ripple through to physical activity, but also looking at sustainability financially in terms of the sugar-sweetened beverage taxes, funding physical activity programs, but also being themselves limited by, if people are drinking less soda, you get less revenue, in. So that whole milieu of energy consumption, obesity, and the investments in the built environment for physical activity, and changes in sugar-sweetened beverage. That's a component of the model Winchell's working on. And we're going to see, maybe we can get a glimpse of that this week if Winchell can make some progress on that. Okay, so implementation science for my colleagues at the NIH, where I have done a lot of work over recent years, or done a lot of also advising. This type of implementation science consideration is often really strong on their radar screens for what they're seeking to get out of modeling. And the picture here is that it doesn't require a totally different sort of model. We can take implementation science elements and we can combine them with these elements we've been learning to build up the past few days and secure benefit from this. Okay? So implementation science concerns can be brought together with this sort of modeling in some useful ways. And this shows one way to do it, through capturing training programs that bear on the capacity to deliver the interventions, and therefore whose progress will shape the behavioral risk factors and thereby the health outcomes achieved. Okay?
And that's brilliant, because you're taking into account all sorts of capacities that would otherwise be assumed away. Like,
that's right.
Is there a place to have children go and be physically active?
Exactly.
And there may be pushback by government who don't want to see the loss of revenue potentially.
Right. Right. It is possible. Yeah. So so a lot of the times the implementation science, if we look at system science application, we look at modeling, for a long time we were dealing with models where the implementation of the interventions we're talking about was brushed under the rug. It was not the focus of the models. The dynamics of the rollout of that intervention was not explicitly considered. But we're in an era where the modeling tools are easily up to this task, and really it's a matter of marshaling the human resources and the sort of understanding of what the questions are on the implementation science side that need to be answered, so that we can effectively integrate them into these models. But the door's wide open for this, and I think we can do a lot better than we have traditionally in reporting findings of interventions once we consider implementation science concerns. Okay. Anyway, that let us a little bit of that model. Okay.